Okay, today is December 7th, 2011. We're starting lesson 7.3. We're going to be working with these three major formulas in chapter 7. Oh, also Pythagorean. You guys should know that one already, okay? Today we're going to be focusing on our tangent ratio, okay? I have what the O and the A stand for. O is opposite, A is adjacent. We're going to talk about those definitions. The short form of it is tangent theta. This is just a variable like x is equal to O over A, which is opposite over adjacent. It's a quicker way to remember it. Okay? So we have the formula written out here. And we need to talk about what opposite and adjacent are. So I'm going to do my first example. Theta is representing an angle. We use theta because that lets us know we're trying to find an angle or the degrees of something. You could use x, you could use y, you could draw a happy face. All of them mean some unknown number. They're just using a symbol. This is a new symbol you guys aren't used to, but theta is just a symbol to represent an unknown angle. Okay? Now, tangent ratio is letting us know what sides of the triangle we need to know in order to solve for this angle. So, tangent is telling us that we need to know what the measurement of the opposite side of the triangle is. So when we're referring to the opposite side of the triangle, we look at where our angle is, and we go to the side directly across from it. So in this case, this would be the opposite side of the triangle. The other side we're looking for is called the adjacent side. The adjacent side is the side touching the angle. Now you guys will notice that's a little bit of a ridiculous statement because there are two sides touching this triangle. One of them already has a name that we learned from Pythagorean Theorem. Yes. So we do not refer to the hypotenuse as the adjacent. The hypotenuse is always the longest side of the triangle. So whenever we talk about adjacent, we're talking about the side touching the angle that is not the hypotenuse. So this is our adjacent side, which means, what is this long side here? That's right. It's the hypotenuse. Which means, if you guys look at our formulas on the other side, you can probably start to deduce how to use those ones. Yep. So, these also, which is very, very important, we only use these for right angle triangles. Now in this chapter, we're going to strictly be working with right angle triangles. But you need to remember that because as we get into non-right angle triangles, these ratios won't solve them for us. So, my second triangle here, again, this is 90 degrees. I want to set up opposite, adjacent, and hypotenuse again. Okay? So I'm going to name this triangle ABC this time. I'm going to ask you guys, which side would be considered opposite of that angle? Yeah, far left, which is our AB. This is now the opposite side. So depending on what angle of the triangle we're trying to solve, the opposite and the adjacent switch places. You guys need to be able to recognize that in order to set up this question. Which means the adjacent is our BC, good. It's the side touching the angle that's not the hypotenuse. Which means, again, opposite of the right angle is our hypotenuse. Okay, so our first example, we have this triangle here. And I'm going to name it once again. Remember, it's always good to name our triangle so that we can refer to things. If I just say top left corner, top right, bottom left, it can be a little confusing, especially if the triangle, it's spun around at all. If we keep the points the same, we'll always be able to refer to a triangle as, let's say, ABC. We'll always know our distances. Okay? So, in this question, where is my right angle? At A, that's right. We have our right angle. Okay? I'm going to ask you to solve for B. Okay? So angle B in this question. We're going to be looking for angle B. And I want us to set up a ratio using tangent. Okay? So, excuse me. This is what we're going to use to remember it. T theta equals O divided by A. Okay, that's our tangent ratio. And the O and the A stand for opposite over adjacent. I shortened them so we don't have to write it every time. Tangent, we're going to call the angle our theta, is equal to, which side would be considered my opposite side? I want you to write the name of the triangle first. AC, good. So our opposite side is AC. And what is considered our adjacent side? AB, good. Good. CB is the hypotenuse. It's the longest side of that triangle. So now that we have those, I can actually input the numbers for them. Tangent theta is equal to, distance of AC was 5, and AB was 12. So there's our ratio. It's as simple as that. Okay. Now I want to actually set it up as a decimal. So we're going to take that, and we're going to start to evaluate. 3 divided by 12. Oh, sorry. 5 divided by 12. Oh, I just said the wrong number. I typed the right number. Tangent theta is equal to 0.4167, I guess. 0. Okay, we evaluated to 4 decimal places. Yeah, we'll say 4 for now. We'll say that we'll do that always. We have example 2, tangent 25. I literally just want you guys to get used to typing this in your calculator. So take a calculator out. Now mine is a little backwards compared to the way you usually write it. Most calculators, you would put tan in, and the word tangent would come up here, and then you would type in 25 equals. If you have one like mine, it's a little backwards. I actually have to type the number first, then I hit tangent. Okay? Figure out which way yours works. Just tan, T-A-N. Right? So I type it in. Tan 25 is equal to, good. Let's try tangent 60 is equal to 1.7. 3. Okay, example 4 we're going to now. They've given us a triangle. Give us a triangle. It's kind of flipped around in the question. There we go. So, in their question, they have a right angle. This is the side X they're solving for. The base of the triangle is 9.2 centimeters. And this angle is 28 degrees. Okay? So, we got to start to make sense of this stuff. Again, let's just name it quickly so it's easy to refer to. Now, obviously, because today we're using tangent, clearly we're going to use that ratio to solve this. But in the future, you're actually going to have to figure out which ratio to use. So, I want you guys to recognize this now. The angle measurement we have is 28. I also have the measurement of the adjacent side and the opposite side. So because I have the adjacent and the opposite side, opposite, adjacent, and the angle, we would be using tangent ratio. In the future, you're going to have to figure out which one to use. Obviously, today we're working with it. So, in order to set up tangent ratio, we take our question. Our theta in this question is 28. Tangent. Now, instead of writing theta in, we write in the number 28. The opposite side of this equation will be what? X. The adjacent side is 9.2. Okay. Now what we need to do is we need to solve for x. So think of this question, tangent 28 is a number, x is a number, and 9.2 is a number. In order to isolate x, what would I have to do? I'm going to have to move something. Yes, we need to move 9.2 to the other side of the equation. So I'm going to write this all in black again now. When I move 9.2 over to the other side of the equation, it becomes multiplied by. Okay? So the way they'll represent it, or you can always represent it in a calculator, is essentially 9.2 bracket tan 28 bracket is equal to x. So what that means is 9.2 multiplied by tan 28. I'm going to figure out what tan 28 is. Okay. 28 tangent. 0. No, because that's division. And when you move it to the other side, the opposite sign is multiplication. That's if you're adding and subtracting, it switches. Okay, so our number here is technically 0.5317, and it keeps going, is equal to x. Now, to be extremely accurate, instead of writing that whole number down, clearing my calculator, I'm going to keep that number in there, and then I'm going to multiply by 9.2. We get 4.89, let's say. 4.89. So the other side of this triangle, x, is equal to 4.89 centimeters in length. Example 5. It says that a radio transmitter is to be supported with a guy wire as shown. The wire is to form a 65-degree angle with the ground and reach 30 meters up the transmitter. So they have some transmitter here, and there's a guide wire. And we also know that the angle of elevation, or the angle that it makes with the ground, the guide wire, is 65 degrees. Our transmitter is 30 meters tall. The wire can be ordered in whole number lengths in meters. How much wire should be ordered? Now, there are two things we're going to have to figure out, because eventually they are asking us to find out how far this guide wire is. Okay? It calls A, B, C. Now, we only have the knowledge to use tangent ratio. So what we're going to do is we're going to solve for this side here, because that is considered the adjacent side, and the other one will be our opposite. Then once we have two sides of the equation, what can I use to solve the hypotenuse? Yes, we can use our Pythagorean theorem to solve it. Now later on, you're going to realize that we could have technically used one of these formulas, cos or tan, and actually we would have used opposite or hypotenuse. We could have used sine to solve this one very quickly, but we're learning tangent today. So we're going to set up our tangent ratio. I take my tangent theta is equal to opposite over adjacent. So we get tangent. My theta is what? 65 degrees. My opposite side is 30. And my adjacent is x. Now in this one, it's a little harder to isolate x. I can't just divide by 30 because on the right side I'll have 1 over x. So I'm going to do this in 2 steps. I'm going to move the x first. And when I move x, because it was divided by, it will become multiplied by x. So our question says x times tangent 65 is equal to 30. Okay. And remember, the whole goal of this is to solve side x. So I need to move what now? I need to move tan over. How would I do that? By? Oops. I'm going to divide by tan 65. Tan 65 divided by tan 65 will just give us our 1. Or in other words, they cancel each other out, as you guys call it. Okay. So we get x is equal to, these two cancel each other out, 30 divided by tangent 65. Now, in many of your calculators, you'll be able to do this in one step. Just make sure you bracket the tan 65. In mine, it's going to be hard to show you, so I'm going to do this one step at a time. I'm going to solve for tan 65 first. So 30 divided by 65 tangent, 2.144. What's that? Oh. Give me 1 sec. $13.99, or we're going to round it to approximately 14 meters. Okay? Now the question isn't done. This is 14 meters. Our other side is 30. We need to use our Pythagorean theorem to actually solve for what we'll call side y, because they want to know how much guide wire to use. So we use our Pythagorean theorem. A squared plus b squared equals c squared. Our c squared is our hypotenuse, or in this case, it's our y. So we have y squared is equal to, we're going to call side A the 30 and side B the 14. Y squared is equal to 900 plus, I'm not sure off the top of my head, 196. Y squared will equal 1096. We square root both sides. Y is equal to the square root of 1096, 33.1. 11 we'll say. Now the reason we round it up to 11 is because if we order too short of a wire, this isn't going to work. So we need to round up so that we have a little bit of room to work with. So the guide wire needs to be 33.11 meters in length. Finally, example 3. Now, again, we have our angle. I know the measurement of my opposite and my adjacent, so we're clearly going to use our tangent ratio. So we have our tangent. We bring it over. We're solving for the angle in this case. So we have tangent theta. Opposite is 2. Adjacent is 1. That becomes really easy. Tangent theta is equal to 2. Now, this is the hard part. Think of tangent almost being like attached to our number here. Like this. Okay? So I can move tangent itself over. Okay? I want to move tangent to the other side. Now, luckily, we've done exponent rules, so I'm going to show you the reasoning behind this, and then I'm going to show you the shortcut. Okay? The reasoning behind this is, because it looks like it's multiplied, we would divide both sides by 10. Okay? These tangents cancel each other out. We get theta is equal to 2 divided by 10. Okay, let's put that in our calculator. 2 divide tangent. Oh, what did that work? That shouldn't have worked. Essentially, you should get a math error. It can't be done that way. So, yes. What we're going to do is, remember, tangent is technically to the exponent of 1. I want to move this so that it says tangent is beside the number 2. So I'm going to flip the exponent. I get tangent to the negative 1, then 2. Now, you guys have this on your calculator. You'll probably have to hit shift. I have to hit shift here. I push 2. My shift button is this arrow. And if you watch my tangent, it changes to tangent inverse, negative 1. I click that button, and we solved for the angle. Anytime we're looking for the angle, we'll be using our tangent inverse, 63.4. So our angle, our theta, is 63.4 degrees. Theta is the angle we solved for. The shortcut to this, I'm going to do in green, or actually I'll do it in blue. We were here at tangent theta is equal to 2. If you're going to move tangent over, we know it's going to become negative inverse, so just go theta is equal to tan inverse 2. Then we plug that in, and we would have got 63.4. You can do it in that many steps if you don't feel like writing all of this out. I personally wouldn't. I would do it this way with the blue. It's a little faster, and it's going to work.